In the second part of Module 4, we have switched from supply network design to distribution network design. So with this sum up lecture, I'm going to summarize a bit what we cover about the characteristic and the analysis of the distribution network. In particular, we have first talked about the role of distribution system. In particular, we have discussed the fact that distribution is a part of logistic, in particular the logistic channel of the supply chain, which realize the so-called outbound activities. And in particular, the logistic channel of the supply chain is composed by two components. One, the distribution system, which nodes are plants, the warehouses, and the point of sale, so everything that comes after production, and the transportation systems, which are instead the arc that connects the node of the network. And here you see represented. So the node are the point of the distribution system, while instead the arc, the arrows, are the part of the transportation system. For our purposes, we have discussed the fact that we just focus the attention on the distribution system and its characteristics. In particular, we have distinguished the possible type of distribution network. To do that, we have discussed that the distribution network can be classified along three different dimensions. So the number of echelons, which are the number of levels that characterize the distribution network, the number of warehouses at each level. So basically, the number of levels here, the number of warehouses in each level, and then the type of warehouse in each echelon. So these three warehouses at the first level can be of different nature. So in order to design a distribution system, you need to understand the vertical dimension of the distribution network, so the number of levels, the horizontal dimension of the distribution network, so the number of echelons, the vertical dimension in terms of the number of warehouses in echelon, and then the nature of each warehouse, in particular in the sense that which type of warehouse of node is characterized by each level. So we've seen different structure. In the slides you find also different type of example. We have seen direct shipment. Direct shipment is the absence of a distribution network where from supplier or plant, goods final product are stocked directly on the plant level and sent directly to the final customer. So goods are delivered from the supplier straight to the customers. One echelon distribution network instead is one level. So one echelon distribution network is where between the plant and the customer there is one central warehouse that fulfills all the assignment of the logistic channel. So the central warehouse receive all the variety that is produced by the different plant, centralize the stocking of this product, and then send out this product to the customer or to the following delivery nodes. Central warehouse can be also special type of warehouse. We have discussed that they can be part of they can support part of the production process, like the stocking in central warehouse for the seasoning of cheese, for the aging of wine, or they can be special warehouse in the sense that they need to maintain the quality of the product because they need to be refrigerated, heated, or where the product need to be stocked at particular conditions. Second type of distribution network that we have analyzed is the two echelon distribution network, where at the first level you have a central warehouse, including all the variety of product that comes from the different plant, and then at the second level you have a series of regional warehouse, which is the characteristic of the regional warehouse, the fact that goods pass through different levels of distribution network from the point of origin to the customer, and while the central warehouse includes all the variety of product that the supply chain brings to the market, The products that are vehiculated to the regional warehouse are only the ones that are served by, are requested by the regional market. So, as I told you in class, regional warehouse 1 in this case has only the product that are requested by customer 1 and customer 2. That's why it's regional, because it has a regional variety. So it includes stock demand only for regional market. Of course, why having a regional warehouse? Because regional warehouses are more proxy to the customer, so they can give higher service level, because they can reduce the cycle time and the punctuality, because they are near the customer and they can feel the demand of the customer and satisfy it in a more effective way. But also they can optimize transport locally, because again they can rely on a smaller demand, they can serve different customer, and so in the region when they operate that they serve, they can optimize the transportation in order to reach all the customer. Also try to understand some where to gain efficiency in the transportation service. Regional warehouses are real warehouses in the meaning that are point where products are stocked. However, we have seen the solution where after the first level central warehouse, there is a further type of warehouse which is called transit point. Transit point is a type of warehouse where stock is only in transit. So stock and inventory is not supposed to stay on a temporary way, but like goods are stocked permanently in a central warehouse and then pass through transit point where they are temporarily stocked and subjected of let's say bundling and unbundling operations, in order then to optimize and rebuild lot which are friendly to the demand that is asked by the final customer. We have discussed in class that transit point. In the transit point, some activities that can be executed can be consolidation of products. So different product coming from different plant can be consolidated in one lot, when instead here are separated in different lot. Break bulk activities, where a lot with different product coming from the same location, coming from the central warehouse, can be like divided, split into different type of product and then vehiculated to different type of customer. Or they can do both operation, and that is called cross-docking. So basically, like product, a huge variety of product is received by different warehouses, different plant, spread all over, and in the regional transit point, this heterogeneous lot are dismantled and rebuilt in order to match the variety requested by the different customer in the final market. Of course, there are cases in which, for some market, we have a serve through regional warehouse. For other market, we have serve through transit point, and for other market, we have serve through direct shipment. In this case, we have a mix, what is called mixed distribution network. So you see here the central warehouse serve directly customer 1 with central warehouse, the regional warehouse serve directly customer 1 and customer 2, customer M is served through a transit point, customer N is served directly from the supplier, and so on. So when you don't see like a clear pattern, this can be characterized as a mixed distribution network. Finally, we have the most complex structure, which is the 3 echelon distribution network, where we have all the type of warehouses that we have discussed before. So at the first level, the central warehouse, at the second level, the regional warehouses, and at the third level, the transit point. Please remember that it doesn't make sense having a transit point before a regional warehouse, because the transit point, the temporary point of stock, is the one that needs to be near in the market. Where this can be done? This can be done, for example, in industry like the food industry, the fresh food industry, where product is subjected to obsolescence or like expiration. So where temporary, like permanent stock is needed to preserve the quality of the product until we are very near the final customer, where we can just like make some organization of lot activities. So in these cases, when the central warehouses are very far from the final market, which is as the case of most of the fresh food companies, because they are like centralized, for example, in Italy, or for example, centralized in the United States, but they sell worldwide. They have regional warehouses which are then followed by transit point. So let's see the case about a company, Altko, which is a local US company which produces lightning fixture to 3 facilities in the Cleveland area, so which means that they have 3 different plants in the Cleveland area. But then it also relied on a solid distribution network made by a central distribution center located in Chicago and 5 regional warehouses, 2 in the east and 3 in the west area, and each one able to sell 3 families of product and their variant in each region. Why? Because probably each region required these 3 families of product. Altko Logistic Manager is evaluating the stock situation in the distribution system. To do that, he has collected some data, and this data summarize the information related to the demand that each warehouse see in the center. So this is the demand seen by the local warehouse, mean and standard deviation. This is the demand seen by the local warehouse 2, 3, 4, 5, and this is the demand seen by the central warehouse, which is the aggregation of the demand seen by the local warehouse. He has also collected information about the lead time needed to realize and transport the product. So from plant to the central warehouse, we need 5 days with a standard deviation of 1.2 days. From the central warehouse to the local warehouse, we need 4 days and 1.6 days. From plant to local warehouse, we need 9 days plus 1.4 days standard deviation. Finally, he has also defined the level of service he wants each distribution center to provide. So these are the key values of each local warehouse and central warehouse in the system. The average cost of an Altko product is $55 and the stock holding rate is 5%. So the question is: draw and classify Altko distribution network and calculate unitary and monetary value of safety stock in the system. So pay attention to this request. So let's see how we can do that. So let's see how to interpret and solve the values of the exercise. So Altko produced lighting fixtures. He has 3 facilities in the Cleveland area and a central distribution center in Chicago. There are 5 regional warehouses and 3 product variants sold in each region. The distribution system looks like that. So you see that we have, pay attention, 3 facilities in the Cleveland areas. Here it is. A central distribution center in Chicago, and we suppose that each plant reach the central warehouse as definition of central warehouse. Then we have 5 regional warehouses, 1, 2, 3, 4, 5. Each one with the 3 products that are sold in each region. So we suppose that the central warehouse reach every regional warehouse, which then sold all the product in each region. So again, don't get confused by that. Like, that's a very easy request. So draw the distribution network, just follow what is written, and then remember, draw, that's the first request, and classify the distribution network. What is that? This is a 2 echelon distribution network. Why? Because first level, central warehouse, second level, regional warehouse, 2 echelon distribution network. Easy. So don't get confused if this may come up in the exam, because it's very easy. You draw it and then you classify. Now, let's try to answer the second question, which is how much is the value of the safety stock? How to read the data? So, these are the data. the demand in the local warehouse and the central warehouse are this one. So it means that in the local warehouse, as I told you, the average demand is 38,440 unit and the standard deviation is 4,040 unit. The central warehouse instead has, of course, the sum of the demand seen by each local warehouse with its standard deviation, which is 123,840 and 4,419. The lead time, so the demand seen by each local warehouse and aggregated demand seen by the central warehouse. The lead time is this one. To go from the plant to the central warehouse, you need 4 days plus minus 1.2 days. From the central warehouse to the local warehouse, on average 4 days plus minus 1.6 and 9 and 1.4 for the plant to the local warehouse. And then we have the level of service. Now, of course, the problem, the idea here is that you need to calculate the value of the safety stock, which means that you have to first calculate the safety stock. It's not difficult, you just have to apply the formula. So remember that the safety stock formula is the level of service multiplied by the standard deviation of the demand multiplied the average value of the lead time plus the standard deviation of the lead time multiplied by the average value of the demand. You have safety stock in the local warehouse and in a central warehouse. So for each distribution center point, you need to calculate the value of the safety stock, which is easy because you have this value for each. For example, for the local warehouse 1, you see, you have the demand average, you have the demand standard deviation, you have the lead time average, you have the lead time standard deviation, and you have the value of key. So, the safety stock is key multiplied by the average value, the standard deviation of the variance of the demand, multiplied by 4, which is the average of the lead time, plus the variance of the lead time or the standard deviation squared or the lead time, multiplied by the average value of the demand. Now, the safety stock in terms of unit is 21,024 unit, which multiplied by $55 multiplied by 5% gives you the inventory keeping cost of the safety stock. Is this the monetary value of stock? Yes or no? I leave it up to you to answer to that, but again, remember what is the request. So the request is to calculate the value of the stock and the value of keeping the stock. Remember that when you calculate the value of the stock, you calculate it by multiplying with the unitary cost of the stocks of $55. If you want the inventory keeping cost, you need to apply to this the 5% percentage, which is the cost of keeping inventory, the CM. And you do that for all the points. So in this case, for the local warehouse, it will be the standard deviation of the demand 4,700 squared multiplied by the average value of the lead time 4 plus 1.6 square multiplied by the average value of the demand 27,490, and you obtain that the value of unit in safety stocks in local warehouse 2 is 24,450 multiplied by $55 multiplied by 5%, it gives you $67,237. You do that. Again, that's a simply mathematical calculation. That's not difficult. You have all the parameters, you just to calculate the safety stock in each level. You sum up everything and you find that the value of unit in the system for safety stock is 140,674.75. Instead, in terms of monetary value of keeping cost, so the cost of keeping stock is $386,855, and that's answered the request. So you're basically putting here the value of the safety stock and in unit and in cost of keeping this safety stock.